the first one I've got is in March of this year. A team of researchers at Massachusetts or MIT at MIT. Yeah, I think it was MIT. They developed a new prosthetic leg that can walk and run on uneven terrain, and so it uses sensors and actuators, right? Yeah, actuators to mimic the basically mimic the human leg, right? So it detects when you're walking and running, and then it's able to do that on uneven terrain, right? Exactly.
Yeah. Wow, that's incredible. Instead of just being a stick,
right?
Yeah, and it's just like a bendable stick. Now you have something that's responsive. That's incredible.
Because depending on so if you are an amputee, right? If you're an amputee below the knee, then those stiff ones, right? They're harder to get used to than obviously a foot, but you can still have, pretty good momentum, right, with that. But I mean, above the knee, you're basically just walking.
Extremely difficult.
It's extremely difficult to mimic the motion of two joints rather than just one that you can kind of mimic.
You're
with
talking about trying to recreate muscles and tendons, and like it's a complex system, and to do that with just two bending joints is not possible.
Right. Right. Because you also have to have the sense of feel, right, and the sense of like pushing, like all of the nerve endings and all of that, like you just said. I mean, like it's crazy. And then last month we had the University of California, Berkeley, and they developed a prosthetic hand that you can actually feel. So it sends nerve endings.
That's insane.
Yeah.
How does that work?
Dude, I'm assuming it has something to do with the just the small little electrical impulses or pulses that you can send to your nervous system is what I'm guessing.
That's nuts.
But to be that specific and to deal with something like a hand that's constantly moving and still keep those sensors, like I could not
and get those signals back to the brain. Like that's difficult. That's just to think, like 2 years ago, that probably would have been an impossible thought.
Oh yeah. Yeah, absolutely. But they can feel textures and they can feel the shape of the object that they're grasping. I don't know if they can feel necessarily pressure, but they can at least feel I'd say a linear level of pressure.
Do you think this was developed in hand with like VR stuff? Because have you noticed that they make those VR gloves?
They do, which are haptic feedback.
And they make you feel stuff. Like you could feel how heavy something. You could like feel an apple. It's round and smooth. Like you could feel it.
I mean, I'm still waiting. I'm honestly still waiting for you to be able to have the gloves, the treadmill, and the headset. Right? I mean, like all of that together.
So I can do nothing. Ready Player One kit.
Ready Player One. That's right. So I can like jump into Call of Duty, grab a gun, and then just feel that gun, and then grab that clip, right? Because I'm just reaching in air, but then I grab that, I feel that clip.
But to feel it,
yeah, exactly.
Yeah.
You can feel
and get the resistance when you're trying to put it in there and stuff like that.
Exactly.
That would be cool.
There would not be a single overweight gamer if that came out, because I would literally burn 2,000 calories a day at least playing Call of Duty like that.
I burn a ridiculous amount of calories just playing VR now. Like 30 minutes in, and I am like sweating, heart is beating. Like you get into it, man. Like I'm telling you, you get exhausted. Like I think an hour is my max with VR. Once I'm in for an hour, I'm like, I'm done. Like I'm exhausted. Yeah.
Oh, that's awesome. That's awesome. All right. Are you ready? Because so that was April, right? Now, this month, University of Michigan has developed a new robotic prosthetic arm that can be controlled by the user's thoughts.
There we go. Now we're talking.
So now, I don't know if it's like I'm just going to reach over here, right? And I don't know if you have to do that versus say arm go up or arm go down, hand go up, hand go down, right?
Yeah, is it like a subconscious thought, like your normal nervous system, or is it like you're really thinking about it?
Right, but to be fair, right, when we were all infants, we had to learn fine motor skills, and so it kind of was like arm go up, arm go down. So if
I don't know about that.
Time,
I don't remember being an infant.
Oh, you don't?
I think,
okay.
I think I was just born a man.
You probably were. Yeah, just came out, hairy chest.
Hair and everything. Yeah.
Okay.
It's all a ruse.
Yeah. But you know what I mean though? We had to learn, right? And so I'm wondering if you wear it for a long enough time, if eventually it does just become a subconscious,
That's a great
reaction.
question. I mean,
So
even if you okay, so if it's like a forward thinking thing, like you have to think, move my arm, no matter
right,
how long you wear it, you still have to think, move my arm, right? Because that's
right,
how the technology works,
right,
right? If the technology was capable of adapting to different signals from the brain, then perhaps it would be a subconscious thought.
right.
But the way it's designed, assuming the way it's designed is you have to think about it, it's just gonna be it's always gonna be that way.
Right. Right.
Yeah.
Yeah. And until you can get it to where it's a subconscious thing, obviously, then
Yeah, you'd have to
But
design new hardware and
yeah,
new
I mean,
software to go with
and
it.
this
Yeah.
is a little bit off of the robotics topic, but I mean, we're getting close, right? On the medical side and the bionic side, right? To
Right.
where we can grow tissue, right? We can
Oh,
grow
wait, yeah,
meat,
we're already there. We
and
can do it.
we're
Yeah.
getting to the point to where we can grow organ, right?
Mhm.
Not necessarily the organ itself, I don't think, but we can grow the cells of that organ, right?
No, I'm pretty sure you can grow a full organ right now.
Can you? I
You
don't
can
know. I
I
don't know.
think, Doctor 3D printed an organ not too long ago.
Really?
Yeah.
That's I know I have heard about those cell printers, which is
Mhm.
that's just
Yeah.
but yeah, I think it honestly on the prosthetics versus the bionics. I hit my mic. The prosthetics versus the bionics, I think you're going to have, a race in and of itself of like, okay, we're going to make the coolest bionic hand, right? But at the same time, it's like you can either choose at some point, it's got to be you can choose. I can have a metal hand that I can punch through a wall, like it's nothing, or you can have another real hand reattached,
Right.
right?
You're talking about
Like that's right.
biology versus bi
Uh, cyborg,
bionics. Bionics,
yeah,
yeah.
bionic cyborg,
Yeah.
basically. I mean, we're already talking about that before. We're about to go into talking about
I'm more
Tesla.
worried about artificial intelligence and things in robotics and things like that getting advanced faster than we can develop technology like that.
Yeah, or will it advance on its own faster than we can implement it to help us, right? Or to
That's what I'm
integrate with
afraid of.
us. Yeah,
That's exactly what I'm afraid of is AI and robotics combining itself, right? And advancing at a rate that
yeah,
we as human beings can't even keep up with.
right,
And no matter what we research or what we do, we're never even going to get to that stage where we get a chance to study immortality or things like that, because
right,
AI
right,
outpaces us and then takes over.
right. Yeah, no, that's absolutely right, and um, that's one of Elon Musk's biggest worries too, and that's why the whole
Not just
Neuralink.
Elon
Yeah,
Musk, like a lot of the heads of the industry are afraid of
yeah.
this. It's in unchecked hands. AI is dangerous.